The following podcast is sponsored by Structure Tech.
So Complete Building Solutions is an engineering firm. It's also a consulting firm, draw, design, CAD. We do everything in the world from blueprints to inspecting buildings to designing things that work to finding problems and shutting down problems, mitigating problems.
Welcome, everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Ruben Saltzman, as we call it, the three-legged stool. On today's episode, we've got a guest alongside us, Rob Vassallo with Complete Building Solutions. And Rob is a longtime friend of Ruben Saltzman and the Structure Tech family. And so we were going to dig into his mind because Rob's a structural engineer and consultant, and he also builds houses, and he's got a plethora of knowledge. And so I'm going to turn this over to Ruben because he's going to guide us kind of into the depths here. Ruben, why don't you fire off some background here and set everybody up. Then we're going to allow Rob to introduce himself, and we're going to set this whole thing up.
Sure. Thanks, Bill. And, I'll say longtime friend of mine, but might even be longer with Tessa. I think Tessa might have known Rob even before I met him. How long have you two known each other?
Since I was in diapers, basically. No, just kidding. Well, fresh out of college, really. So I guess, what was that? We were just talking about that. What was it, like 12 years ago we met?
Something like that. I think so. Yeah, it must have been at least 10 or 11 years ago.
How did you meet Ruben, Rob?
Well, I think it started, we had some real bad ice dam years. 2009 was a real bad year, but for ice dams in Minnesota and the region, we had several real bad years where every home in the Twin Cities and thereabouts had ice dams. And so it became quite an issue. And since Structure Tech, even back then, was one of the better home inspection companies, they kind of knew what they were doing. So we asked Ruben to come in because I think at the time he was the president of the Association of Home Inspectors. And so even, beyond what Tessa and I had done together a little bit with Steve Scherber, we have always been involved in the science of buildings, just like Tessa is and just like Ruben is. And we had actually asked Ruben, when we heard of him, to come in and talk with us so we could show him what we did in the world of mitigating ice dam issues.
I remember that. We sat down and you showed me your whole process. And it's not like you're a company who comes in. I think what you do is really unique. And wait a minute, hold on. Let me back up. We haven't formally introduced you yet. We just started talking about connections. So Rob Vassallo, Complete Building Solutions, or CBS. And you guys fix problems with buildings, and you're also an engineering firm. Am I leaving anything out?
No. So Complete Building Solutions is an engineering firm. It's also a consulting firm, draw, design, CAD. We do everything in the world from blueprints to inspecting buildings to designing things that work to finding problems and shutting down problems, mitigating problems. We have a long history in my company with engineers anywhere from 32 years old to 80 years old. And with my experience also as a 48-year home builder, remodeler, there's really nothing we don't miss. So we have a plethora of devices and systems and products that really work in the building industry, in the home and commercial building industry, that are time-true and tested, and there's nothing we can't do as an engineering firm.
That sounds pretty impressive. So now we know who you are, so let's get back into how we ended up meeting. I ended up coming out to your place, and you were sharing with me your whole process for what you guys do on ice dams. And I think what you guys do is really unique in that it wasn't that you're actually doing the repair work. And correct me if I'm wrong, but you really weren't interested in single family homes, right?
Right. Actually, we delve into anything that is a building in the region, mostly Minnesota, but we also hit other states. Any building that's in this region is going to be tested with Mother Nature winning most of the time. And the way that building codes are so minimal, the standards are so minimal, if it's a real tough year with 50 below to 110 above with high humidities, a lot of buildings are not going to be successful in warding off warm meeting cold in the envelope, warm meeting cold in the attics, that kind of thing. Buildings are going to be tested. And so that's where we spend most of our energy, is making sure that buildings, homes perform when we are done.
Sure.
If that makes sense.
Yep.
Yeah.
And so what you were doing at the time, that what really intrigued me was you would be scoping out work for entire townhome associations. You were
Yes.
really specializing in that, and you'd have whole associations coming to you saying, look, all of our buildings are failing. What's the solution? And then you would design what needs to happen. You would work with the insulation contractor to do all of the repair work, and you would oversee the whole project, kind of as
Right.
a third-party quality control consultant or something like that. I don't know. I'm making up these words. But that sound
Yeah.
about right?
Yeah, the way it usually starts, you have a complex that's in trouble. They hire an engineering firm to come in and do forensics and find out what's wrong. We then go building to building to building, put together a stamped engineer report that shows building by building what's wrong and what has failed. And then we meet with the board, and a lot of times we get invited to annual meetings with these townhome and condo associations. And we have to actually put it up on the screen and show people why they're suffering, why the building doesn't work, why it's not performing, why they have ice dams, why they have water in. So we get invited from A to Z a lot of times with these associations. Because they're managed by management companies and they have contractors that give them bids, a lot of these associations don't really get what they need. So the smart ones end up going to engineers. And when an engineer is involved, he's going to get to the root of the problem. He's going to put together a package of what's going to make the buildings perform the first time, and not just do a roof or not just do siding. They're actually going to get the true science of the building. What's wrong? Here's how to fix it. Here's the scope. Now go get your bids. And then a lot of times they will hire us to do the project management, where we will actually oversee the entire project, from the tear-off re-roof to the insulation, to the ventilation, to the vapor barriers, to the waterproofing. There's so many things involved depending on their problems, but a lot of times we do get hired from A to Z, which is from inception with forensics all the way to project management, to signing off on what the contractor has done to ensure that these buildings, now that they just paid a big dollar amount for, are going to perform year in and year out.
So what's the most common stuff that you end up seeing wrong in attics that leads to ice dams, where you say, look, all these buildings have to have all these things fixed? Just hit the high points.
The biggest culprit is that when they build these places, a normal home takes 9 months to build. And we'll get into dehumidification later, but it takes 9 months, 8-9 months to build a good home, to go through every single process to make sure you don't have problems in the first 10 years. So what we find almost every single attic I've ever climbed into, 99%, I find that a lot of times there was never a ceiling of bypasses. And that code is as old as 60, 70 years, to whereas before it's insulated, the lid has to be sealed. Every single bypass that goes from the third floor or the second floor into the attic has to be sealed. Otherwise, there's a transfer of energy, usually through warmth, getting up into the attic to bypass the lid and get into the attic, starting problems. So the number one culprit is sealing bypasses, Ruben.
All right. Now, I got to touch on something you just said there, Rob. You said that this has been in the code for 60, 70 years. I got to ask you about that one, because I don't feel like we even knew what a bypass was. I feel like nobody even understood that until the early 90s, 80s, or any time before then. There was no such thing as sealing an attic bypass. How is this required?
Actually, there was, because we've been in court for this so many times, Ruben, that we've really done our homework. If you go past the old Minneapolis codes, the UBC, which they used to call a uniform building code, which there was no such thing. If you go back to the Department of Energy and even go further back, sealing bypasses has been around forever. I might be off a little bit on 60, 70 years, but not very much, because we end up as experts in lawsuits at the head of a case, and we have to do our diligence. And this is an issue that has come up many times. And sealing bypasses, if you even go back to the U of M and their Department of Energy, sealing bypasses goes way back. Way back.
That's encouraging to hear. I like it. Not that it's going to affect what I do on a day-to-day basis. I mean, if it's before 1990 or so, I just assume that it was never done. But that's interesting to hear. So it was an energy code type of thing that came through the UBC.
Well, I mean, if even look back as short as when they started Type 1 units, The older homes were less than type 1. They were built to have air infiltrate. If you look back during war times when they had no money and they put spaced roof boards on and they didn't put insulation around windows and they had the old dumbbells in the double hung windows, the homes back then were designed to air condition themselves. But when you get into the 50s and 60s, they definitely decided to change how they built homes. They were not type 1 back then that were super tight. You had to introduce outside air. But this started back in the 50s, 60s all day long.
Interesting. So attic bypasses is huge. I kind of had a feeling you might say that. What comes next?
What comes next is the actual insulation. In the realm of what's important, it starts with the insulation and the ceiling, the bypasses. Then it moves into the insulation and the R value. Okay. Thirdly, it moves into the ventilation. So number one, you have to stop any energy leaving that home at the lid, at the ceiling. Okay. After that, when you have an R value that's up to code, it's 44. They want to move it to 49. They keep changing, the R value and the vapor barrier. But third in line is definitely the ventilation, which is whatever the temperature is outside and the humidity level outside, the attic should mimic that. It should never be warmer in the attic than the outside area. So third is ventilation all day long.
And what do you do for ventilation?
Well, there's 20 things you could do. But again, Ruben, as you know me, I carry the term of turbinator in Minneapolis, St. Paul, because I've been at the helm of installing over 40,000 turbines in my tenure.
Wow.
And again, I knew you'd bring this up.
Yeah.
The reason I will never advocate a ridge vent, I will never advocate a dead vent, I will never advocate a fan, an electric fan, which both has a humidistat and a thermostat. There's two types of electric fans. The only one that really does the job is a turbine. And the reason being because if you have good soffit intake, that's where the cold air comes in. It's drawn in by the turbine, and the turbine is exhausting any air that does get into the attic. With the intake of the soffit, it exhausts the attic 24/7 without electricity. It's why I love turbines.
There was a term you used there, dead vent. What are some other terms for a dead vent? I think I know what you're referring to, but that's the first time I've heard someone say dead vent.
Yeah, a dead vent could be a turtle vent. It can be a box vent, but they're passive. They're solely passive, and they allow air to escape if the wind is moving, or if the attic has a lot of heat loss, the air will eventually get out of a turtle vent, dead vent, box vent, 750. You can call them just about whatever you want. But they're just a dead vent that's 9-inch by 9-inch exhaust is the size of what it's supposed to let out. But they don't cause intake and exhaust. They only allow passive exhaust when there's wind or when there's heat pushing. Other than that, heat can sit and just stabilize in the attic and rarely move out sometimes.
So you're a huge fan of the turbine vents. And how much wind do you need outside to get a turbine vent to ventilate your attic?
Well, you can get by with 1 or 2 or 3 miles an hour. It doesn't take much because they put such good bearings in them that they mostly turn on their own just from warm air coming out of the attic. Even if you have a really well done attic with all the bypasses sealed, high R value, there's still a lot of times where a furnace exhaust will come through the attic and they're hard to shield. And so you have at least 2% of the heat loss in the attic is still there sometimes when you have a furnace exhaust or something that lets off hot air. So turbines will turn even without wind, a lot of times just from the heat emanating. But even if you have a 3 to 5 mile an hour wind, you're still going to pull about 350 square feet of air out of that attic every hour.
So, Rob, just a clarifying question. Are you saying that you would recommend turbine vents in any attic or just attics that have been air sealed?
In just about any attic. The only attic that I would not advocate turbines on is a true vault. So anything like a church sanctuary or a real true vault in a home that each cavity has to exhaust, that's the only time I would ever, call out that a ridge vent would be put in place. Other than that, every other type of attic, I would call out turbines.
So I guess another question for you, Rob, is that like in the building science world, I know that there's talk about concerns with having, a turbine vent creating a negative pressure in an attic and actually pulling warm, humid air from the house into the attic space through attic bypasses and actually making that attic warmer and creating moisture problems too if the humidity is leaking in the attic. So is that a concern that you have, or I guess have you done enough attics and put turbine vents in attics that aren't perfectly air sealed and not seen any issues?
That's such a great point, Tessa. Yeah, in that case where somebody will not create that barrier between the conditioned living space and the unconditioned attic, if they don't take the time to install the proper sealing of bypass and or an 1.5 inches of urethane, which would get them that thermal break that they need, the vapor barrier, then in that case, I would let them know, hey, if you put in turbines and don't solidify the lid, you're going to create more of a problem. What a great point you just brought up. Yes.
Okay. Why wouldn't you recommend that? I guess, so it's the moisture issue. That's why you wouldn't recommend it on like a vault ceiling, like you were saying, right?
No, it's a mechanical issue. It's actually an engineering issue, whereas if you have a true vault, you have to exhaust every rafter cavity in that attic.
Yeah. Okay. I gotcha. I can picture that now. Yep. You're saying it's not effective at cooling the whole attic space because it's divided up by each rafter.
Exactly. It would only exhaust one rafter wherever you put the turbine, and nobody wants 22 turbines on their home.
Correct.
We just got to get someone to invent like some 4-inch turbines.
They do make smaller turbines, Ruben. They make a 15-inch, a 12-inch, and they actually make an 8-inch that I haven't seen for a long time. But if you go to Canada, they make every size turbine in Canada because every roof has turbines.
Wow.
Oh, man.
I love Canada even more than I already did.
So another thing that I've heard people complain about is these turbines seizing up, like bad bearings. I think I know what you're going to tell us about this. What do you have to say about that, Rob?
That's a thing of the past. The bearings that they put in these turbines are stellar and they're lifelong guarantee. So if the turbines are installed out of plumb, and you're in an area like North Dakota where you have no trees and the wind really makes them turn every day and they're not installed perfectly plumb and level, yes, they will burn out a bearing. Also, the old turbines used to be metal bushings. They didn't have turbines in those days. So back in the 50s, 60s, 70s, when they had bushing turbines, those really did make noise in about 5 or 6 or 7 years in windy years. So it's not really a fallacy, but the way that they make them, like Lamanco turbines, they're amazingly constructed and the bearings are lifelong warranted.
Well, I'm sold. So can I order some Lamanco turbines from you? Just kidding.
Yes, Lamanco actually loves me, yes.
I bet they do.
Rob, can I jump in here and I want to reverse course a little bit because you mentioned two things at the beginning of this conversation that I think is really important that we focus in on. You talked about designing a project through the lens of an engineer. And then after you go through an engineering company, then you pass it off to the contractors. If you do that, what kind of expense are we adding to the job cost?
It's usually 7 to 10%. What a great question. If there's project management involved, after the engineer's been out, done the report, shown the condo association what's wrong and how to fix it, if they decide to hire the engineering firm to project manage, it's anywhere from 7 to 10% of the total project.
Okay, so 7 to 10% to manage it. How about to do the engineering to get it set up so the contractors know the scope of work?
Great question also. That's anywhere from $600 to $5,000 depending on the size of the complex and how many buildings we have to investigate. It goes by the number of units and whether they're vaulted ceilings or flat ceilings in those associations.
Great. Thank you. That helps a lot.
I'm just curious, on your type of analysis, initial analysis, is it all just visual where you're like looking at the building from the outside, climbing the attics, or do you do additional testing like with blower doors and infrared cameras and all of that?
Yeah, we don't need blower door tests by any means. A lot of times, Tessa, when you're outside and it's October or November, and I look up at the roof and I see rafter lines on the shingles, little ice lines, like it was, say it was 20 degrees the night before and it was humid out, 78% humidity, and I pull up in my truck and I look up at the roofs and I see white rafter lines on every single building. Before I even go in the building, I know what's wrong. Mm-hmm. And we used to do negative blower door tests back when you were working in our shop, Tessa, and we would find the readings at 1,400 when you did your test. And when we left, it was around 700. So we knew that it would solidify. But a lot of people don't want to spend money on all that testing when they can hire an engineer who's been doing this their whole life and can put together a report in a week and hand it to the association and the board and say, here's what's wrong and here's how to fix it. We don't get involved in all the science that you do and that you have done, even though it's worth its weight. But the reason that I don't push towards that, Tessa, is because we've been doing this so long that we already know every attic we're going to go into is basically probably done incorrectly.
Yeah, it's interesting.
Yep.
Rob, there's a lot of like insulation contractors that would say the same thing you do. Like you give them a house built in 1970 split level. They don't need to do a blower door test to know where the attic bypasses are. They already know just pulling up to the house.
Exactly. Yep. And I'm not poo-pooing what you have done in your tenure. I know you're amazing at what you do. You're a scientist. You really know the buildings very well. And I don't know if you're still doing blower door tests or not, but they are worth their weight if somebody's not going to hire an engineer. Okay. If somebody just wants to hire a scientist like yourself to know where all the leaks are in the home, that's a great way to do the test with a thermal camera.
I agree with you that you don't need to do a blower door and IR to find those things. When you've been doing it enough, you just kind of get a good feel for it.
Exactly. Yeah.
Rob, second point here I wanted to back on is you dropped this nugget. It takes about 9 months to build a house, or it should.
Yes, sir.
You want to dry it out correctly. So I don't know if a lot of people, when they go into their building project, are planning to have their construction loan in place for at least 9 months. The idea is the faster we get through this construction process and I can get to permanent financing, the better. But tell me, why 9 months?
The reason 9 months, especially with a townhome complex or even a high-end home like I've built in the past, there's about 40 days involved, maybe 50 days of removing moisture from the lumber package. When the home is framed and the windows are in and you haven't done insulation yet, there's about a 40 to 50 day period where you need to run dehumidifiers. And the reason being is because whether there's rain or not, several times on the project while you're framing and the subflooring gets wet and the framing got wet and the trusses sat on the ground getting soaked and the roofing plywood got wet 3 times before they got any felt paper on it, there's a period of 40 to 50 days where you have to dehumidify the lumber package when the home is shelled. So once everything's put together, the windows are in, you plug up the soffits, you plug up everything, you run 3 big blue dehumidifiers for about 40 to 50 days. And the reason being because most builders, when they close up a home, they leave about 15 to 20% moisture in the lumber package. When you dehumidify it, you can get the lumber moisture down to about 4 to 5% before you close the house up, before you insulate. That process doesn't stop any of the mechanics from working. You can still do high vac, HVAC, you can still do plumbing, you can still do electrical. Everybody can keep working, but you have to have that process, that timing of drying out the lumber before you close up the home. And I'll give you several reasons why if you want to know.
Can I just ask a quick question? Is that after you've installed the weather-resistant barrier, the siding, and the roofing material?
You can do the roofing and the siding before you do this, yes. Yes, you can definitely. Well, you want to dry out the top anyhow, and you want to keep the sides from getting wet. But this is for all of the inside where the conditioned air is going to be, Tessa. Okay. This is to take the moisture out of the lumber inside of the home before it's closed up. Yes.
Okay.
Yeah. So share with us, why is this so important, Rob?
Well, one of the big reasons this is so important, there's a reason that window manufacturers only have a 10-year warranty on their windows. And in the first 2 years, when you build a home and you don't dehumidify and you close up 15 to 20% moisture in the lumber from the floors to the framing, to the roof, to the trusses, to every piece of lumber in that home, if you don't take out the moisture in the first year when the home is closed up and insulated and sheetrocked, the greatest energy gain and loss is at the glass, okay? I mean, number one, it's normally the ceilings where the heat gets through, but if a builder did a good job with a good vapor barrier, with a good insulation, with a R value, blah, 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 the heat doesn't get through the lid. But what happens is in the first year and then the second year in the winter, when you close up 15 to 20% moisture, the glass where the greatest loss and gain is, that's only an R value of 1 at best on the windows. It's hard to get any more than that. So when that happens the first winter, that loss at the glass, at the windows and the patio doors and that kind of thing, actually draws moisture from the lumber in the walls, in the envelope, to the glass. It's why so many times that you have lawsuits and window manufacturers giving people new windows, because the windows go first, because they actually draw the moisture out of the lumber and right up to the greatest energy loss, which is the windows, patio doors, that kind of thing. So it's crucial to make this entire package last, not just the windows, but to keep warm from meeting cold. Because if you start the cold season with 20% moisture trapped in the envelope, well, guess where that's going to go? It's going to diffuse. Diffusion ruins homes. It's why I'm a stickler about dehumidifying during the building process so that when I close up a home, my moisture content in the walls is 4%.
Well, do you measure that?
Oh, of course.
I think it's so funny that you're calling the window a dehumidifier.
I'm not calling the window a dehumidifier by any means. I'm calling the window the greatest loss of energy and gain of energy in the house.
Okay, well, maybe you're not calling it that, but there's another blogger out there named Allison Bales. He's got this blog called the Energy Vanguard blog, and he has called windows a dehumidifier.
No, I'm sorry if you took it that way. I'm talking about real dehumidifiers. I'm talking about a machine called a Dryzair. It's 4.5 feet tall on wheels, and I run 3 of those during the building process before I insulate the home, before I sheetrock the home. I take the moisture content out of the lumber with a dehumidifier as I'm building that home. Sure. I'm calling the glass the greatest loss and gain in the home, okay, in the world of diffusion, where the moisture, when it gets to 50 below or 30 below that first winter, and that changes at the glass, the diffusion actually pulls moisture out of the lumber towards the glass from the framing behind the sheetrock. But it also ruins the home from within. I mean, look at the Type 1s in Wisconsin. Remember 15, 20 years ago when they started to build, or 20 years ago, they started to build Type 1 units. You had so many homes in Wisconsin rotting that there was lawsuits everywhere. And of course, they had double vapor barriers. They had other reasons for that happening, but they were also closing up homes with 20, 25% moisture in the lumber. Well, that's going to show up in the first 2-3 years. The homeowner's not going to see it, but in the envelope, it's actually rotting the home from the inside out.
So how many builders today do you think are following this process and they're drying out houses?
There's only 3 that I know of, the 3 that I have met with. I don't know if you want names on air or not, but there's some really...
Yes, please.
You're saying good stuff about them. Let's hear.
Sven Gustafson is a great home builder in the Twin Cities. Stonewood is his name. You've also got Mark Lisi, who's a really great remodeler, home builder. Mark, the Lisi brothers, also dehumidifies. And there's one other one that I'm not sure if they ever started doing that or not. I don't know if it was Denali. There's a group of home builders right in that area in Minnetonka, and they're right next to Denali Homes. Do you remember their names? No?
I do not. Just for anybody else listening, we'll make it clear that these aren't the only people who do it. It's just the only people that you know who do it. So we're not knocking any other builders, but
Me either.
I'm giving a shout out to these guys for sure.
Well, yeah, I actually met with them decades ago, and I brought this to their attention because when I took on the engineering firm, as an old home builder, I care about home builders because they get in trouble all the time. So as an old home builder, I came to them because some of them got in trouble and needed engineering help. And they asked me to then come in and speak in front of their entire office and show them what works so that they stay out of trouble with lawyers. So those builders that I had met with took it on and decided to put that into their process because it doesn't slow down the building process at all. Mechanics can still work, but they really didn't want the problems on the back end with high moisture content in the homes. It's a nightmare.
Sure. Makes a lot of sense. And besides windows, I mean, you end up with other problems too, like drywall cracks and pop nails and all other kinds of things that homeowners hate, right?
Exactly. And nobody can ever figure out, and builders will tell them, some builders will tell them, well, that's settlement cracks. And then they'll hire us to come in and I'll say, no, there's no such thing as a settlement crack. Somebody closed up high moisture content and it showed up in the second winter. If you have a real bad winter with just the right humidity or the lack thereof, or just the right coldness 4 days in a row, these homes can't withstand that. Mother Nature is going to win. So you cannot close up a home with 20% moisture. It's just that simple.
I think it's a good title for this podcast. There's no such thing as a settlement crack. I think we just came up with that. Can you expound on that a little bit, Rob? I want to hear more on that.
Well, I know that you hear that every day because you guys are the best home inspectors out there. And I know of the 100 home inspectors that I'm sure you hear that all the time. And I kind of giggle every time I hear that from a homeowner who hires us to come out and tell them what's wrong with their home.
And I don't like to badmouth builders by any means, but that's a terrible thing to tell people. I've built some really high-end homes, multi-million-dollar high-end homes that never showed a crack anywhere. It's because I took the time to do these steps to ensure that I didn't get a call back 5 years later or 10 years later or somebody bad-mouthing me. I really didn't want that.
So I'll admit, I've used the term settlement crack a gazillion times because you're doing a home inspection and your clients look at this little hairline crack and they're like, oh, is my house falling down? And that's my stock response. Like it looks like a settlement crack. But so how would you describe it, Rob?
Well, it depends on what I find. We come in with moisture testers, sometimes a video borescope to see what's in the walls, for insulation. Did they use a double vapor barrier? There's 20 things that would cause this problem. So I can't give you a blanket comment on that until I saw the project and I did some testing. There is some testing involved, but if a home is built in the 90s or 2000 and it's got hairline cracks, that's a pretty good indicator that they either cheated on an LVL or a span or they cheated on moisture content, trapped in the walls before they closed it up.
But that's one of the reasons why I don't think home inspectors should be opining about why this, that, or the other is inside these buildings. I don't inherently believe this building's going to fall down because I see these cracks, but I think all too often we want to give some peace of mind, which, maybe you say the right answer that time, but chances are there could be a false positive in your statement.
Totally. Well said. Right. And that's why there's so many times during the week that one of the best home inspectors out there will send people our way and say, you know what, you need an engineer. I could probably tell you what this is. I could do some testing. I've got a moisture tester in my pouch. I'll see how much moisture is behind the sheetrock or in the sheetrock. But you know what? This is best left to the professionals. And that's why I get so many phone calls from Structure Tech.
Rob, do you recommend doing like a major dehumidification after they sheetrock and mud and everything, tape and mud?
No, that's a great question, Tessa. You're not going to get the moisture out of the lumber. You're going to get the moisture out of the mud, okay? But a lot of good drywallers will run not only a heater, but a dehumidifier, but that's so that they can do their second coat of mud right away, okay? Now, the one thing that nobody ever talks about also is once you do sheetrock and you're done with your mud and tape, there should be a vapor barrier paint. Benjamin Moore makes a vapor barrier paint that I put in every one of the homes that I've built, which actually keeps any moisture in the conditioned living space in the conditioned living space. It never makes it through the sheetrock. It never makes it into the attic through the lid, the sheetrock. Every home that's ever built should have a vapor barrier paint on the sheetrock before they put any colored paint on it.
And that doesn't create a diaper that you have to be concerned about?
No, sir. No, because the type 1 homes that are built in the last 20, 30 years introduce outside air anyhow. Okay. So whatever you do for humidity, whatever you do with a humidifier on the furnace, you should have 30 to 35% humidity in the home, but it keeps your conditioned living space as that air. It never permeates the sheetrock. That's why I always call for a vapor barrier paint on the inside of the homes.
Hey, Rob, would you recommend a vapor barrier paint in a hot, humid climate?
Well, it depends on the mechanical system. It depends on what the HVAC people are doing, how they're moving air. But again, I want a barrier. The conditioned living space has to be the conditioned living space. It can never meet with the envelope in any form or fashion. There can be no transfer, no diffusion, nothing.
Sure. To come back to your engineering services, I mean, just to kind of wrap this up, that's also a service that you offer is individual evaluations on single family homes. If we do a home inspection, and I will qualify this, I'll say we are usually quite hesitant to recommend engineers to do anything, because if we just go in on every inspection and all we're doing is saying, oh, you got a crack here, you get an engineer, we're going to be calling you out every time. And at that point, it's like, what's the value in having a home inspection? So we are hesitant to do it, but you're definitely on our list. So, we got a lot of inspectors. So we do send business your way. No question about it. What's an average cost when you're going out to a house to check out a problem for a homeowner? What's your process look like there, Rob?
It's usually about $600. To be very to the point, we're $300 an hour for engineering. There's a 2-hour minimum on residential, which takes into account the engineer's time, load calc, load path, the report, stamped engineer report. So from A to Z, it's usually about $600.
Okay. So that's right in the same range as what we're charging for home inspections. That's,
right. And again, to go back to what you just said about your home inspections, engineers can't do what you do, what you guys do. There's no way. We're not going to go from the top to the bottom and look at every aspect of that home like you guys do. You have it down to a science. Engineering is a whole different world. We're not going to look at 200 things in a home and put a report together in a day. That's your deal. We are specific. When people have a concern, we are specific on that concern or 2 or 3 concerns, but we can't do what you guys do. You guys are worth your weight.
Thanks, man. Rob. And back at you.
We love you guys.
Rob, one of the selfish things I get to do because I'm on the podcast is ask professionals questions I would otherwise have to pay for. So I'm going to throw one at you here. We're rebuilding a cabin on a piece of property we have on a lake up north, and we're going to start in April. And I was hoping that we would be able to be moving in our furniture by the end of the year. But what you're saying is we need more time to dry this envelope out.
No question.
Okay, so a little building like that, do I still need the 40 to 50 days of drying time?
Well, it depends. Is it all going to be opened up? Is it going to be exposed right to the outside sheeting?
Yeah, because it's going to be built from the ground up.
Oh, it's a brand new build. Yeah, then you definitely need to do at least 30 to 40 days. But if you have a simple moisture tester, you'll know when you get the moisture down to 4, 5, 6%. Just don't close it up with 20% or 15% because you're going to ruin the home. So yeah, it's going to, unless it's a real small space and you have 2 big dehumidifiers, Bill, it might only take 20 days. You'll know because you'll have mechanics working inside, touching each other and getting sparks. You'll know when it's negative energy in the house because the mechanics will get sparks touching each other.
Funny.
Well, thank you.
All right.
Thank you. So we can stop my project now and go back to the podcast. I appreciate it.
Now we got to do my project. If you're doing it, I'm doing it, Bill. I just ran to the store last night and picked me up one of those solar tubes made by Velux because I love those things. Tessa, I don't want to hear about it. So knock it off. I love those things. Rob, talk me out of it.
Well, I have a lot of experience with those tubes also. And as long as you get the insulated chute, the insulated tube, I'm okay with you doing that because they do add a lot of light. They don't cost an arm and a leg. They are worth it. But if it's just the aluminum, they let too much heat into the attic. Does that make sense, Ruben?
Yep. And that's not what I'm doing. I'm doing all aluminum, man.
Oh, no way.
I'm not doing the insulated tube.
Hey, your house can be a case study for ice dams then.
I've actually done testing on those tubes in townhome complexes. And when I go up into the attic and I shoot with my laser thermometer and the attic is, at 20 degrees and I get to that tube and it's at 48, you got a bit of a bypass there, bud. So at least insulate it if you're going to put one of those in, okay?
All right. So you said the insulated tubes. I got to tell you, in my time as a home inspector, I have never seen an insulated tube. Can you describe to me what this looks like?
Somebody comes in with a urethane gun and sprays it after you install it.
Oh, big eye roll. I'm rolling my eyes. No one's coming in with a spray gun.
Get a frost pack. They don't cost that much. Use it to seal up bypasses while you're in the attic, and then use it to spray that aluminum tube going up, okay?
Okay. All right. Sounds good. Tessa, what do you have to say about this?
I was going to say that's exactly what we would do. Our scope of work on houses that typically had problems with ice dams. And I remember finding solar tubes going through an attic space and just the radiant coming off of them would be enough to warm up that attic and melt the snow.
Exactly.
Okay. All right.
Well said, Tessa.
I'm sorry, Ruben. I can tell I just crushed you there. I crushed your hope of a beautiful solar tube going through
It's already in my garage. It's in my garage.
But it's not too late. You haven't cut holes in your roof or your attic yet.
It's just a good thing he hired you. I'll tell you that, Tessa. The voice of reason. You're the VOR now.
Thank you, Rob, very much. I'm going to jump in here. We should probably put a wrap on this episode, but I say this on every episode where we have a guest. We just scratched the surface of this conversation. So thank you, Rob, very much for your expertise and the information that you provided. It's a joy to be able to tap into contractors with your level of expertise and your broad band of knowledge it's just amazing. I'm humbled by how much people know, right?
What a lovely thing to say. That's so nice of you to say that. And you guys, when you need me, just call. I could do podcasts with you all the time if you need me, okay?
Thank you, Rob. That is very kind of you. Can you tell everybody how they can find you on the web, via phone, all your particulars?
Find us at cbsmn.com. We're right in Golden Valley, Minnesota, or they can call my cell phone at 612-868-2922.
Awesome. Thank you again. Everybody, you've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich alongside Tessa Murray and Ruben Saltzman, and we will catch you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.